Hello, hello. How's everybody doing?
Doing pretty good, and you?
Hanging in there. It's Thursday, so it's always good, right?
Mm-hmm.
Anyone going to the Educator Rising meeting today at 2 o'clock? That's a resounding no. I'm going. You guys know what I'm talking about? The Rising meeting?
Yeah, Beth sent an email. It's extra credit from my other class.
So are you going?
No, I have to go to work at 2.
Oh, got it.
Mm-hmm.
Okay. All right. I'm freezing in my house and I don't know why. I'm just having a freezing attack. I think I've been sitting down too much. So like my circulation is gone. So I'm just freezing. All right, we're gonna do warm up of kind of finishing up yesterday. Okay, and then we'll chat about Thunderbird Thursday. I should probably connect to the class. All right. Can you do this problem an alternate way, right? Don't do normal long division, do alternate long division, some alternate strategy, and then we'll talk about how that relates to our integers again. And then we'll do some order of operations problems. Who is iPhone? Can you tell me who is iPhone? You can just text it. I mean, you can just chat it if you can't talk. Okay, perfect. Karina, I figured it was something. Oh, love when our computer's frozen. I had that problem this morning. So far, so good. We'll see. I don't see Amanda, Sarah here yet. Oh, look, there's Amanda right there. Is Brianna here? Yay, Brianna's here. Sorry, I let everybody in because I was having tech issues right before. And Betty's here. And Elena's here. And is Sunita here? I don't see Sunita yet. All right. Sarah's here. Sarah, I don't know why I didn't think you were here. I can see you right there.
Hi.
Okay. Weird. Hi. Okay. Did somebody do it an alternate way that they want to share? How did you do 462 divided by 3? Nobody wants to share. That's so sad.
I'm still working on it, but I did.
Okay.
Well, I'm using partial quotient
Yeah.
to solve it. So, hold on. Okay.
Guys are working. Did you see that I updated all your midterm stuff is in? Yes.
Yep, I
And
saw that.
all zeros got put in if anyone was missing assignments. So make sure you take a look at that. Okay, Bethel, are you
Okay.
sharing?
So yeah, I don't know if y'all can see it, but I did partial quotient. So I did 3 times 100 to get 300. I subtracted that from 462, got 162. Then I went to 3 times 50 to get 150. I subtracted that from 162, and then I got 12. And then 3 times 4 is 12 with 0 remainder. And so I added
Very
up.
nice.
Yep.
Hold it up so we can all see it. Hold it up there. Okay, now I want everyone to look at it. It looks very nice. Do you agree with her answer, first of all? And then second of all, is there anything you can do or anything you noticed when she was explaining that would put a plus on her? Because she did a great job. But I just noticed something and I heard something. Did anyone else?
Can I put it down?
I noticed a
Adding
little
the
thing. I don't.
subtraction in addition.
Wait, okay, first Hannah, and then I don't know who else was talking. Hannah, you go
Sorry, I'll
first.
let Hannah go.
Sorry. You have your 3 times 100, 3 times 50. All that's very nice. I don't know how important it is that you put it next to the product of that, but like your 3 times 100 should probably be next to the 300, and then 3 times 50 should probably be right next to the 150, just to avoid any confusion that way.
Yes, good point. So does that make sense, Bethel? Do you see what she's saying?
Yeah.
Okay, good. And now Betty?
I was just gonna mention the signs, adding the plus or the minus sign on there.
Yes, so adding some subtraction signs when you're actually subtracting, that's very helpful. Good job. Anything else?
Where she put the answer?
Yeah, I mean, she could circle it or she could put it up on the top. Either way is fine, but yep, that's a good one. Did anyone notice something that she said? You can put your board down now, Bethel.
Okay.
Did anyone notice something she said? I'm very, very picky, right? MP6, attend to precision. When she was speaking her explanation, did anyone notice something? I'll say it and tell me if you catch it. She said, I multiplied 3 times 100 and got 300. Then subtracted 462 minus 300 and I got 162.
She included the and.
Ah,
I
yeah,
remember this.
bad habit. You know why Betty heard it? Betty, do you want to tell them why you heard it?
Yeah, go for it.
Because Betty likes to say and as well. And it's just a bad habit that we get into. In everyday language, we say it like that. So then you said it again, Bethel, when you said, then I multiplied 3 times 50 and got 150. And then I subtracted 162. Actually, you said I subtracted 100. I can't say it. 162 minus 150 and got 12. So get rid of those ands. Okay, practice, practice. But you did great. By the way, did you notice I said she had A work, right? It was already an A. That just puts a plus on it. Yes? So great job, Bethel. And thank you, Hannah and Betty, for pointing those things out. Some of you who are a little quieter, like, oh my gosh, that was so mean. No, 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 right? That's not, we're trying to just be precise. That's why Bethel volunteers, right, Bethel? So you can practice.
Yeah, go ahead. Just use me. I need the practice.
Yeah, it's good for everybody. It's good practice for everyone. Okay. So, and then I don't know if this was the problem on the worksheet. I feel like it was, but I'm not going to pull it up. If I took the same problem and did 462 divided by -3, or if I did -462 divided by +3, or if I did -462 divided by -3. right? Then remember we talked at the very end of class yesterday, kids will literally do the problem 4 times. And you'll be like, no, 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 no. How about we use information we know, right? If we already know the product of 462 and 3 is 154, then let's use that information and think about our signs, because that's the only thing that's going to change. Yeah?
I have a
Okay, good.
question.
Yeah, I'm ready.
So if we have, say, the problem 462 divided by -3, do we or do our students need to put that negative in the problem when they do the big 7 or whichever strategy they're using, or can they just acknowledge that there's a negative there and put it in the answer at the end, or not if it's 2 negatives?
Absolutely. The latter is true. So just have them acknowledge that that negative will be there. Now, if you have a student that constantly forgets their sign, you might want to have them figure out the sign in advance, right? So they could go through and go, okay, I don't know what the answer is yet, but I know the answer to this is negative. I know the answer to this is negative, and I know the answer to this is positive. If you have a chronic sign forgetter, and that will be the reminder for them to do that in advance.
Cool, thank you.
Yeah, good question. All right. Excellence, this was on your video. Yes, your video assignment. The difference between 6 squared, -6 squared, and -6 squared, which, how do we read these so they're different? So that's challenging because we do really read them both the same way. We read this -6 squared and this -6 squared, but the difference is this is actually taking the value -6 and squaring it, which is 2 factors of -6, whereas this is saying the opposite of 6 squared, right? The opposite. So this one will turn out negative, this one will be positive, this one will be positive. That just helps you, right? How many of you learned that for the first time in this class? Because it really bit you in the booty in algebra, right? It got you big time in algebra if you weren't careful. Yeah. So, and if we really focus on the language and the meaning, I think it's more helpful. Okay, let's try these. Try these 6 problems. I'll give you plenty of time, like, I don't know, 4 minutes. And then oh my gosh, I'm gonna pull up my wheel. It's gonna be so fun. And I'm gonna find all of you guys. We're gonna pick you. Yeah, it's gonna be fun. Let's see if I can find it. You guys work. I'll set a timer.
I need to move classrooms real quick. Sorry.
Okay. Okay, did you finish all of them? Nope, almost. Okay, about 1 more minute. Okay. If you're done, can you put your hand up like in the little reactions thing? You know how you, not that one, maybe, yeah, the one where it says raise hand, like I just did it on mine. Just so I know who's done and who's not. Nice, and you can just leave it up. Okay, put your hand up if you're done, like in the little reactions thing, like in the little thing, so I can see who's done, because I can't remember. If you can't find it, it might be over in participants for you, but there should be a little button that says raise hand, lower hand. Like, do you see in my window? Can you guys see everybody's hands up? Oh, can you see my hand up? There you go. It's in the upper left-hand corner. Like, not my real hand, like my cartoony hand. That's weird. I don't know why some of them are done. Okay, so we're gonna start. I think some of you are close. Sydney, are you done now? Bree, are you done? McKenna's done, Jessica's done, Karen's done. Hannah L, are you done? And Kelsey, I know you got kicked out, so you might not be done yet. Okay. It's okay if you're not done. Just if your name comes up, tell me. So let's see if it shows up on here. Can you guys see a spinning wheel? Oh, guess whose names those are? They're yours. It's like pick a stick live. Yeah, it is. Karina, so lucky, Karina. I don't know how you have such good luck. Just kidding. Okay, so what did you get for your answer for number one? I will allow you to pass, just so you know. If anyone needs to pass, you can.
Okay, so I did my best because sometimes these trip me up. So can you see that?
Tell us your final answer. I think I can see it.
Okay, I got 20 for my final answer.
Anyone agree with 20? Nice, you got some. Sorry, I have to put all these hands down. I don't know why I can't put everybody's, oh my gosh, now I'm putting people's hands up. I don't know what's happening. Okay, it's okay, I'll put them down. Okay, good job. So 20 is the answer to the first one. Okay, let's look at the second one. I think it's B, right? I think they're lettered, not numbered. I have way too many windows open right now, so I can't really see what you think I can see. So there you go. Oh, isn't this fun? You feel like you're playing Wheel of Fortune? Yeah, it's true. We are. Kelsey, I don't know if you could see them all because you got kicked out of the meeting. Do you have B done? Uh-oh, you're breaking up pretty bad. Do you want to just type your answer in the chat? You can just say, I'm not done or whatever, too. We have lots of internet issues today. Okay, Kelsey said she got 1. Did anyone else get 1 for that one?
I got
-9.
-9. Betty said she got -9.
That's what I got
Okay.
too.
-1.
Oh, okay. So do we need to do this one?
Yeah.
I think
Maybe we need to visit this one. Okay, hold on. So let's do part B. So we have division, division, and then here's multiplication, right? Between those two is multiplication. So what are we going to do first?
Work left to right.
Work left to right. Very nice. So -24 divided by 4 is -6. Now we're going to do, now we have this. -6 divided by -2 times -3, but we're still going to do the division first. So -6 divided by -2 is +3. Now +3 times -3 is -9. You agree now? Yeah. Sometimes copying the problem down is the hardest part. I agree. I make those mistakes a lot. All right, let's look. Let's go back to my little spinning wheel, but I lost it. That's very sad. Where do you think it is? I bet it's here. Yay, isn't this fun? You guys are like, no, it's not fun. Sunita, you just arrived. You won't have these done, so we'll spin again. McKenna, it almost got you, Sydney. Were you hoping? Were you hoping? Okay, C, what'd you get for C, McKenna?
So for C, I got 6.
6. Anyone agree? Anyone disagree? We got lots of agrees on that one. Okay, good. Maybe it'll come up next, Sydney. It's okay. Essie, I'm ready. Do you have D?
I got 3.
Everyone agree? Anyone disagree? Oh, good. Look, we're all doing so well. Okay. Sydney, I hope it comes up. I hope. I'm just torturing you, Sydney, because you're right in front of me. Jessica.
I got 23.
23. Anyone agree? All right. Last one. I know it's sad. It's okay. We'll use the wheel more. Kelsey already got picked, so we won't pick Kelsey again. Tyler. F.
I got 53.
53. Do we agree? Okay. So some of us just need to practice this more and more and more, right? I picked ugly problems, right? I picked ugly problems. By the way, in case you're wondering what that app is, it's called Flippity. Yeah, I don't know more than that. I could find it again if I needed to, but Flippity. I have some classes, people are a little less willing to participate. So then I use Pick a Stick or something like that. But in an electronic environment, sometimes they think I cheat, right? And I'm picking the same person on purpose. So I like Flippity. So Evelyn, I don't know if you could use Flippity with you, because you might have some online students or something like that. It's kind of fun.
We use something like that. I don't know if that's the exact website, but we use a spinning wheel too if we are online.
Yeah, and that website has lots of options besides the spinning wheel. You can group students, you can do lots of things. It's very cool. Okay, and Alyssa had a question.
I do. Can we do F? Because I had trouble on that one.
We can. The first thing I would do if you're having any trouble with order of operations is I would use a highlighter and I would highlight all the operations, because that's going to help you make sense of what's there and what I need to do. So now I didn't highlight operations. I highlighted those signs. Those were not an operation. What I was going to highlight was this, because that's multiplication. So I have division, multiplication, subtraction, and multiplication. So I know that, and some of you are like, wait a minute, there's parentheses, right? Because kids do this a lot. There's parentheses. Well, there are parentheses, but those parentheses aren't showing you grouping symbols. They're actually showing you multiplication. So that can be a little tricky for students because there's nothing to do inside the parentheses, right? It's just holding -3 and holding -4. So we're going to go left to right. 26 divided by 2 is 13. I'm going to write the whole problem because that's a great strategy. 13 times 5 is what's next. And 13 times 5, you could use your strategies, right? You could do 5 times 10 is 50, and 5 times 3 is 15, and 50 plus 15 is 65. Yeah, did anyone do that? I did. Okay, guess it's just me. Okay, so don't forget about those strategies. They're still there. Minus, and then I have -3 times -4. I have to do this multiplication next. So -3 times -4 is going to be +12. And then I have 65 minus 12, which is going to be 53.
That's where I messed up. I just kept going.
Left to right?
Yeah.
Yeah, so you did 65 minus -3.
Times -4.
And then you multiply by -4. Yep, very common. For some reason, we magically feel like we can change subtraction when we're on a multiplication and division roll. Yeah, it's a weird happening. Okay, everybody good? Questions, concerns? Okay, I saw most people did the assignment last night. Good job. Excellent. The prime and composite assignment. I did want to talk to you. I know a couple people in here talked about their scholarships that came up, which is awesome. We also have, it's Club Rush Week. I can put that link in the chat if you guys want it. If you're interested in any clubs on campus or you want to start your own club, you could at MCC. And we do have an Educator Rising meeting at 2 p.m. today. 2 p.m. if anybody is going. If you don't have the link and you want to go, I'm sure I have the link in my email because I'll be looking for it to go. Okay. So any helpful hints or info on scholarships that anyone wants to give anyone else? Anyone have their scholarship all set up already at ASU? They have their full tuition scholarship already? I had 2 students last semester who have it. Karina, are you on your way?
I had my meeting with my advisor and I'm like super close. I just have to like finish off the semester and then like it's almost in, I guess, but I'm really close. So
Nice. Good. And I did get an email from NAU that they want to come and talk to our class. I just don't feel like we have time. But I was going to tell her maybe she could just send me her info and then I can send it to you guys. Is anyone interested in the NAU info? A few of you. Good. Okay. I'll make sure I get it for you. Okay. Remind me if I don't have it to you by Monday, let me know because I'll make sure. And wait, Jessica wanted a clarification on problems like D. We always do the division last. I'm going to look at that. Problem D. Great question. It was the one with the fraction. Yes, you treat them like they're separate problems. So you simplify the numerator using order of operations. You simplify the denominator using order of operations. And then your last step is that division of the fraction. Great question, Jessica. All right. See, all good. Your Civ assignment that you did, what does it mean to be prime or composite? Can you write an answer in the chat for me? What does it mean to be prime or composite? Don't hit enter yet. Get your answer ready in the chat. Prime versus composite. All right, ready? 3. Oh, not yet. Okay, if you're not quite ready, it's okay. We're gonna do it. 3, 2, 1, go. So everybody look at the chat and read through them and make sure like who you agree with, who you liked the wording better, those kind of things. And if you weren't finished, just hit enter when you're ready. All right, so what do you think? Whose definition do you like? Most of the time when you read all the definitions, you're like, oh, not mine. Like, I don't like the way I wrote mine after I read everybody else's, right? Some of you are on board with that.
I think
Some of
Tyler's
them are
good.
Tyler's is good. Let's look at Tyler's. And some of them are a little problematic. You're gonna need to be careful, right?
Hannah
After you read
Miles.
somebody else's, you're like, oh, Alyssa.
Hannah Miles, I like hers because I didn't know composite. And then when she said it, that I'm like, oh, well, I knew that.
Okay. So Tyler says prime numbers have only 2 factors, 1 and itself. Composite numbers have multiple factors greater than 1. I like it. You guys have so many in here. I have to do a search for handouts. Can't even find it. Okay, here we go. A prime number has only 2 factors, 1 in itself. A composite number has more than 2 factors. Any other ones that we like? Evelyn's, short and accurate, like the wording. Let me find Evelyn's. I can't even find Evelyn. Oh my. Where is Evelyn? Somebody read me Evelyn's if you're looking at it.
I could read it to you. Prime
Okay,
numbers
perfect.
are numbers with 2 factors, and composite numbers has more than 2 factors.
Nice.
I should have put that.
I just found it, by the way, because I made you read it. So prime numbers are numbers with 2 factors and composite have more than 2 factors. Here's a question. Is 1 prime or composite? The number 1.
Neither.
Neither. Because it doesn't meet either of those criteria, does it? Right? How many factors does the number 1 have? 1. Yeah. So it's not prime because it doesn't have exactly 2 factors, and it's not composite because it doesn't have more than 2 factors. So somebody put in there that it has to be odd. Is that true?
Okay, I have a question about this. So
Yeah.
that more number theory homework, I think question 8 was what's true about prime composite numbers, and I spent like 15 minutes on that one problem, and I had to keep redoing it over and over because, thank you, Vanessa, it's so confusing because I thought all prime numbers had to be odd and all composite were even because they're all divisible by 2, but clearly I'm missing something here.
So tell me the smallest prime number.
2.
2. Is that even or odd?
Oh. Oh gosh.
Welcome. So yeah, 2 is the only even prime number.
I see.
Right? Yeah. So, and I'll look at that question. I don't want to make you cry, right?
No,
If you,
it's
if you,
okay. It was good.
It's
Yeah,
okay. I did the same thing. I redid like number 8 like 3 times. I was like, what am I doing wrong?
yeah, sometimes that wording is really tricky, right? Okay. All right. You learned something, and I think somebody had it in their chat. It might have been Madison's thing. So reflecting on your sieve of Eratosthenes, how do you find the largest prime number you need to check to see if a number is prime? And I think Madison says you take the square root of the number and you have to test all the primes less than that, right? If you test all the primes less than the square root of the number, then the number must be prime. How many of you knew that already? Did anyone know that already? Bree did. Anyone else? Yeah, does anyone understand that rule, like where it came from? Did you figure it out when you were doing the sieve?
Would you be able to explain it to me a different way? Because it like makes sense, but it doesn't.
Yeah, I can try.
Please.
And I can try, and then somebody else, if they understand it or can word it a little bit differently as well. So we did our sieve, we had a hundreds chart, right? We had the numbers 1 to 100, and we marked out the number 1 because it wasn't prime or composite. And then 2 was our first prime number. And we eliminated all multiples of 2 because all multiples of 2 cannot be prime because they have a factor other than 1 in itself, and that factor would be 2, right? So, and then we continued it. We went to the next prime number, which was 3, and we eliminated all the multiples of 3 because every number that has 3 as a factor could no longer be prime. And then we didn't have to look at 4 because 4 is a composite number. So we looked at 5, and we did the same thing. We eliminated all the multiples of 5, right? Because they're all divisible by 5, or 5 is a factor of them. So there's no way they could be prime. We didn't have to look at 6 because 6 was already composite because of 2. Then we had 7, and 7 is a bugger, right? When you look at 7, because you're like, oh, first of all, the multiples are a little harder of 7. When you were shading, well, it was nice because the computer did it for you, right? If you do it with kids and you do it by hand, it's a little more challenging. And when you shaded the 7s, I hope you saw the patterns on the hundreds chart, so you could kind of make sense of that. But, and then you thought, okay, all of those are eliminated. Then you didn't have to look at 8 because it's composite, and you didn't have to look at 9 because it's composite. And then we were done with the entire hundreds chart. Did you notice that? But we only went up to prime numbers less than 10. Yeah. What is 10 squared? 100. Yeah. So somehow we found all the prime numbers less than 100, but we only checked prime numbers less than the square root of 100, which is 10. And that's because those factors are duplicated in there, right? Because of that idea of squaring. So does that help a little bit, Betty?
Yeah, I think it was just the wording. Like it makes sense, but if somebody to tell me explain it back, I'd be like, oh, that's what I was wondering.
Yeah, it is a hard one. And kids don't usually know this theorem, right? This isn't a theorem that's usually taught. But it's a nice, as a mathematician and a teacher, it's a nice one to know. So then when you're testing primes, you know where to stop, right? Okay, so try these two. Determine if the number is prime or not. But first, you should probably figure out the largest prime you need to check. So do it for 557 and 437. Some of you were already doing it probably when I was sitting there talking. But do it again. And then we'll spin the wheel to see who's going to answer. It'll be so fun. All right. Good. I know everybody's having Wi-Fi trouble today. That's why I'm just letting it go. I don't know what's happening, but the world is having trouble. Let's see who the big winner is. Madison, you are lucky. I see you, Madison. Okay, Madison, you can have your choice. Do you want to do 557 or 437?
I'll do 557. I didn't get to the second one yet, but I'll
Okay.
so do I just say, oh wait, so do you want me to just say my answer?
Sure.
Whether it's prime or composite?
Sure.
It is prime.
And why? How do you know?
Because I checked the square root, which is about 23.6, and every prime number below that does not go evenly into 557.
So you checked 2, 3, 5, 7, 11, 13, and 17, and 19, right? Those are all the primes less than 23? Do we agree? Yeah. So some of the things we might know, like it's not even. So I know it's not divisible by 2. It doesn't end in a 5 or a 0, so it's not divisible by 5, right? Then some of the other ones I might have had to use long division. If I was a kid, I would have to use long division. You could use your calculators, right? I mean, I hope you could use long division if you needed to, but you can use your calculator. Okay, you all
Wait.
agree with, yes.
I'm kind of, so you would just multiply like 23 with 3 to see if it fits, or like I'm still confused on how would you do
You
that?
divide 557 by 3. So you take the original number and you divide it by each one of these prime numbers. And if there's no remainder, that means it's a factor of that. So then it would have a different, it would have more than just 2 factors. So then it would be considered not prime or composite. Better, Bethel? Okay. Everybody okay with the first one? Okay, did you get to the second one yet? Yeah. Okay, I'm spinning the wheel then. You can pass if you need to. Vanessa, did you get to this one?
Yes, I did.
Okay, what'd you get?
I got no, it's not a prime number.
Okay, and why?
Because I first tested how we did with 557. I tested the 1 and then I did whatever was divisible by it.
Did you find the square root of 437?
No, I didn't, but I can do that right now.
Just because that tells you where to stop. Okay.
20.90.
Yeah, so the largest prime we would have to check is the same, 19.
Yeah.
So we're gonna, so we're gonna check them. And what factor did you find that it's divisible by?
Well, I got 19.
437 is divisible by 19, so it's not a prime since there is another factor, and you could say that factor is 19 besides 1 and 437.
Yeah.
Good job, Vanessa. So if you hadn't found that 19, you might have kept going. And so it's just nice to know where you need to stop.
Yeah, I actually, this is funny. I would just like kind of like what we did for 557, see what it would be divisible by, and then just go based off that. But yeah, I should have done that first. It would have been a lot easier and shorter instead of like testing.
Yeah, for sure. Okay, so does everybody understand that idea and how that sieve works? Nice. Okay. Some of you already started this assignment, the Freyer model, factor versus multiple. Yeah. I'm going to put you in your breakout room so you can just chat about it a little bit. But if you already finished yours, don't give all your answers to your whole team, right? Like make them think a little, right? You don't have to do all their homework for them. So, but if you've never seen a Freyer model, this is a Freyer model. It was named after Freyer in 1969, and it's to identify and define unfamiliar concepts and vocabulary. Teachers don't do vocab enough in math, and it's really important. I like doing two Freyer models, one on factor and one on multiple, and I like my students to show them side by side, so then they can compare and contrast the differences. And we do this in class, and we talk about them, so we can make sure we're not making mistakes, because these two words are probably the most misused words in math, factor and multiple. You have to be really careful about your meaning. So all Freyer models look very similar to this, where you put the word that you're looking for in the middle. Okay, so one of your Freyer models will have the word factor, one of your Freyer models will have the word multiple. If you don't have the Freyer model, I can put it in the chat for you, so you have it. I know it's in your assignment too. Then the boxes are, you write a definition, characteristics, examples, and non-examples. Some people think it's weird to keep non-examples, but non-examples are nice because when students are doing it, they'll write the wrong one, right? So they'll write examples of factors on their multiple Freyer model. And if you're walking around facilitating and you talk them through it, then you go, well, what could you do with those numbers? And they go, oh, I'm just going to move it to non-examples instead of examples. And that's great because they're not going to make that same mistake again. Okay? So does everybody know what you need to do? I'm not going to give you too long because I know some people are already done, but just kind of briefly go through it. You'll find some boxes harder than other boxes, I'm sure.
Can we have like an example? Oh, sorry.
Go ahead.
Of a characteristic. I'm probably just overthinking it, but what does that really entail?
A characteristic would be like, how do you identify it? Right? And I think once you start thinking about it, you'll list some characteristics. I don't want to give them away. Okay, does everybody have their Freyer, or you can just draw it on paper? Okay, I'm going to put you in your breakout rooms real quick. Oh my gosh, my little clicking is having a problem. Like that little clicking means my brain apparently. Okay. I only have Betty in room 7. I don't know who's in group 7.
Vanessa and Kelsey.
I just put Vanessa in the wrong room because I was just being a weirdo. Okay, if you're not in a room yet, you will be in a minute. Hi, Michaela.
Hi, I think you put me in group 4 and I'm supposed to be in group 3.
That was hilarious. Sorry about that, Michaela. That's okay. I
Oh,
put
you're
Karen
fine.
in group 2 and she's supposed to be in group 8. So I don't know what happened to me. My clicking I must have lost my mind for a minute there. Poor Sydney's all by herself. Okay, you should get it now. Did you see it now?
Yes, perfect. Thank you.
Okay. Thanks for telling me. Hi, Hannah.
Hey, it just kicks me out. I don't know.
Nice. That was fun. It's okay.
Yeah.
I was closing them anyway,
Oh, okay.
so you're good. Welcome back, everyone. I know that was fast. Some of you are like, I did it before class because I know it's always too fast. I get it. Okay, so let's just go over briefly what you wrote down, and let's go to that characteristics category because I do think that's a challenge for some people. So tell me a characteristic, whether it's multiple or factor, any group.
All even numbers will have number 2 as their factor.
All even numbers will have 2 as a factor. Very nice. McKenna, was that what you were going to say, or were you going to say something else?
Well, we were kind of originally thinking like factors had to be either even or odd, but we realized that they could actually be either. So that was just kind of going off of what Evelyn said.
Nice, good. Anyone else have a characteristic?
Is mentioning that it has to be a whole number, would that be a good characteristic?
That's a great characteristic, that it has to be a whole number. Excellent. Anyone else?
Well, kind of the same rule for 2, 5, any number that will end in 5 will have 5 as their factor as well. That's
Okay,
another
any number that ends in 5 will have a factor of 5. Nice. Did either one of these remind you of skip counting? Does everybody know what skip counting is, right? If I say skip count 2s, you would go 2, 4, 6, 8. What am I listing there when I'm doing that?
Aren't you listing multiples of 2?
I am listing multiples. So you could write skip counting under a characteristic of multiples. And Karen wrote in the chat that a factor is when you divide and there's no remainder. So that could be one of your characteristics, or it could be part of your definition if you wanted. So look at this statement I have on my screen. I have the first one, number 1, 18 is a factor of 9 and 2. Think about it and decide if that's true or false. Just the first one I have. Am I sharing my screen? I hope, yes. So 18 is a factor of 9 and 2. Is that true or false? Just think about it for a few seconds. All right, so is it true or false?
False.
It's false. Why is it false?
Because factors are the like 9 and 2, not the sum, not the answer of 9 times 2.
So 9 and 2 are the factors of 18. So what is 18?
The multiple.
18 is a multiple of 9 and 2. So the number 2 is true. Number 1 is false. Yeah. So, and that might help you write some things down. That might help you say, okay, think about this. if I'm trying to list factors, what's the biggest a factor could be? Say it out loud, McKenna.
The number itself.
Yeah, so multiples, factors, they can be is the number that you're given, right? So 18, factor of 18. Other factor of 18, less than. Factors must be less than the given number, yes? They could be less than or equal to. We should probably say less than or equal to. How about multiples? How big can they be?
Can't they go on forever? I mean, can't they just keep on going, right? Until
They can keep on going forever. So what's the smallest a multiple can be?
The number.
The number itself. See how you could write those characteristics? And Betty put in the chat something that's connected to what Madison just said. What?
I sent you a message saying if I could mention that on the characteristics, that there can be an infinite number of multiples as a characteristic.
Absolutely, which is what just getting. You should keep going forever. So there's an infinite number of multiples. Is there an infinite number of factors? No. So what's the opposite of infinite?
finite? I don't know. Is it?
All right, it is finite. So there's a finite number of factors, but there's an infinite number of multiples. Do you see how you could write those in characteristics? Yeah. So what are some examples you wrote down factors or examples of multiples?
Well, for factor, you could do like a factor tree. So we did 30 and then we did like branches off for 10 and 3 because those are two factors of 30.
Nice. Are there any other factors of 30?
Yeah. Oh yeah, for sure. Like you could then go with the 10 and do 5 and 2. And then you could also do 15 and 2. So there's a lot of options.
Yeah, exactly. Good. How about multiples? Give some examples that you wrote under multiples. I have no just in case it gets too quiet. Madison, why did it pick you again? Oh, Betty put it in the chat. Good. Multiples of 2 are 2, 4, 6, 8. Madison, did you have a different example?
I did the multiples of 20, which are 1, 2, 4, 5, oh gosh, 10 and 20, right?
Wouldn't that be
Do you agree?
I disagree with her.
Why, Betty?
Because that would be the factors of 20.
Oh.
Those would be factors of 20. So Madison, slide that over to your non-examples category.
Okay, I'll do that.
So examples of multiples of 20 would be what? The smallest it can be is 20. And then we're going to go 20,
Is
40,
it 40, 60? Okay, so then you're just adding 20 each time, right? Those will be multiples.
Yeah, or you're multiplying, right? 20 times 1, 20 times 2, 20 times 3, 20 times 4. So, and Madison, I'm so happy you said that incorrectly, because that's exactly what happens in a classroom. And then you say, it's okay. You can just slide that over to your non-examples category. Because if you made the mistake once, you're going to make it again. You might as well write non-examples that are reasonable to confuse, right? Okay, so work your way through that. I think the only one we didn't answer was definitions. And if you have to look it up, you can. but try to write your own definition without it, just because I think it's more fun. Okay, McKenna started talking about prime factorization when she was looking at 30. And she said we could split it into, I think you said, what orders that you split it into?
First I said 10 and 3.
Okay, so 10 and 3. Now, if we're doing prime factorization, we want to break it down to only prime numbers, right? So only prime numbers, we're done. 3 is done, right? Because 3 is a prime number. So I'm going to circle it. But 10 is not a prime number. So I must be able to break that down more. So I can break 10 down to 2 times 5. Now I have all prime numbers for 30. Excuse me. So my prime factorization for 30 is 2 times 3 times 5. Every number is a unique prime factorization, right? Otherwise, it would be the same number as something else. So this is called a tree diagram or a factor tree. Some of you have learned this before. Some of you don't do it like this. Is there anyone who does it like this? Yeah, okay, Karen, nice. A lot of our students that didn't grow up in the United States or have other experiences learned it differently. Karen, teach you to always start with 2 if you can? Yeah, so they teach you, if you learn this method, they say start with the lowest prime number, which would be 2. And then Karen, tell me if I'm writing it wrong, because I don't write it this way very often. Okay, so now I can't fit any more 2s inside of 15. So I'm going to the next prime, which is 5, which is 3. I was saying the answer after my division. So, and then I say, how many times does 3 go into 15? 5 times. And then I notice that 5 is a prime number. So here is my prime factorization, 2 times 3 is 5. Is that how you wrote it, Karen? Nice. So sometimes this is called the ladder method. I don't know why it's called the ladder method, maybe because it looks like ladder, I don't know. So tree diagrams or the ladder method, I don't know what you use, whichever one you're more familiar with. Some of you who learned this way, try the method because it's definitely a different feel. So let's just do one of these. Do the prime factorization for 504. So if it's an even number, start with 2 just because it's the easiest to break it down. Now, you can use some of your multiplication strategies instead of picking up this device every 2 seconds, just so you know. So if I'm going to say 2 times something, I want you to think about that. What's half of 500? 250, we know that. Then what's half of 4? 2. Right here, I'm going to 252. Do you see how that will give you 504? Those are all those multiplication and math strategies that we were talking about. We can do it again, right? Because it goes into it again. You might go, oh no, now I don't know how many times 2 goes into 200, but you probably do. 250 is $1.25. Half is
$1.25.
And half of 2 is 1. It'll be 126. Keep going. And then if you want to, you can write out your prime factorization with exponents, right? Because it doesn't matter. So you could 2 times 2 times 2 times 7 times 9, or 2 to the 3rd power times 7 is 9. I'm okay with that. You've done factorization before. This should be nothing new. You might not
Wouldn't you
have to do it.
split 9 into 3 and 3?
Yes, sorry. Thank you. Thank you. I don't know who said that, but thank you for saying that. Yes, because 9 is not prime, it's composite. If we've learned nothing else today. Okay. Now, you can do prime factorization all the time. Prime factorization is very helpful with fractions, which is what we're headed into, right? So that's why we want to practice those kind of things. This is something that's a little of a side note. So maybe I'll make a quick video on this. It's not something you necessarily need, but I can show you in a video. Sometimes we have to know how many factors of something there are, or has anyone seen rainbow factors like this in class where they write, okay, factors of 12, there's 1 and 12, and then you go 2 and 6, and then you go 3 and 4. Anyone seen that before? Okay, so I'll make a video for you on that. You don't need that for your homework. Divisibility rules. How many of you know the divisibility rules? Some of you do, some of you don't. Amanda said in the chat ages ago that there's a trick for 3s. Did you know the trick, Amanda?
Yeah, I did.
Okay, and what is the trick?
The sum of you find the sum of the digits, and if that number is divisible by 3, then the original number is divisible by 3.
Nice. How many of you knew that? Yeah, some of you did. So if you don't know the divisibility rules, I have a super fun activity. We just don't have time for it, and it's much more challenging online to do this activity. But a lot of you knew the rule for 2, right? How do you know if something is divisible by 2? It's if it's an even number, right? Some of you, all of us, know the rule for 5. If it ends in a 0 or a 5, then it's divisible by 5. So I don't think I can write on this document. This is your divisibility rules homework. So if the last digit is even, which in other words, it would be 0, 2, 4, 6, or 8. The next word that goes on here is if the sum of the digits is divisible by 3, then the number is divisible by 3. The rule for 9 is very similar. If the sum of the digits is divisible by 9, then the number is divisible by 9. We already went over 5. I'm sure you know 10 ends in a 0, right? But did anyone know the rule for 4 and 6 before this? Most people don't. The rule for 4 is a little tricky. It says if the last 2 digits form a number that's divisible by 4. So for example, if I look at the number 216, I don't add those last 2 digits. I just look at them and say, oh, 16 is divisible by 4. So 216 is divisible by 4. Does that make sense? So that one's a little bit different. The rule for 8 is very similar. It's not on this sheet. Rule for 8 is the last 3 digits. If the number is divisible by 8, by the time I did that, I could just divide it by 4 and then divide it by 2, right? So, but let's look at the rule for 6. Does anyone know what goes in that blank? If the number is divisible by both, does anyone know what it is? What are the factors of 6? 2 and 3.
2 and 3.
Right? Yeah, so the rule is if it meets the rule for 2 and it meets the rule for 3, then it's going to be divisible by 6. Kind of convenient to know. Kind of nice. So let me just clarify this. If I need to, I can make a video on this as well. I don't know if there's a video for this. Down here, what you're going to do is, do you see how it says on a separate sheet of paper? So you need to use a separate sheet of paper. and you're going to show me how the divisibility rules work. You're not going to show me long division. Yeah, you're not going to show me long division. You're going to show me like 84 is divisible by 2 because it's even, right? 84 is divisible by 3 because the sum of the digits is 12, and 12 is divisible by 3. Yes? And you're going to do it for every single one of them. So you're going to say 84 is not divisible by 5 because it doesn't end in a 5 or a 0. It's going to seem like a lot of work, but it's going to reinforce those divisibility. You can circle the ones that it's divisible by on this paper, but on a separate sheet of paper, I should see your work for each divisibility rule. Yes? And I shouldn't see long division.
Do you want us to write it when it is divisible and also why it's not divisible?
I want you to write them all. Yep, I want you to write them all. Okay? All right, I know it's time. I didn't get to LCM GCF. How many of you know LCM GCF already? Yeah, you've heard it. Try your homework. If it's really problematic, email. Okay, if it's really problematic, email me and I'll consider doing something. But read the directions on the assignment. I don't think it's that terrible, but I can make a couple videos for you guys too. Let's go back to our exit ticket. If you can't do it right now, just do it in your leisure, your exit ticket. I don't even remember what it is because I wrote several days ago, because I know some of you need to go. I hope I see some of you in the Educators Rising meeting. If you can't make it this time, maybe you can make it next time. At least get on the list if you're interested in the info. Oh, there's an element of GCF on the exit ticket, but I don't think it'll kill you. If you get them wrong, you get them wrong. They don't count against you. Stay here if you have any questions. Otherwise, have a great weekend.
I have a question about the, I guess the home activity on the integers.
Yeah.
I just want to make sure that I'm supplying the right amount of screenshots and not too many. So I'm just going to use one as an example. It just says +8. Now, essentially, you don't want me to send you 8 screenshots of me adding 1 plus sign each time, right?
No.
You just want to see like the display of it?
Correct.
Okay.
You can even, like in mine, I just used the Google Doc and I just took a picture like in my virtual manipulative, and then I just inserted it right under that question.
Yeah, that's what I
right
put
in my Google Doc. Yeah.
Okay.
Sorry, is that home integer operations? Is that the one? I'm just looking at it to be sure.
I actually also, it's in regards to what Alyssa said. So for, what was it? So for 16, you said you wanted step by step. So since it was division, it kind of threw me off for a second, but then I was like, okay, never mind. I'll just take, so what I did was I just did the 16 negative chips. I took a screenshot of that. And then I did the groups of 4. I think it was, yeah, the groups of 4. So like, would that be okay for like 2? Do you want a screenshot for every time that it's into groups of 4, or just when they're already in a group of 4?
Yeah, when they're already groups of 4. And why did I not make this a Google Doc for you?
Yeah, and then
hold on, I have a Google Doc. I'm gonna change it to a Google Doc if you want to use mine.
Okay.
So it might be easier. Go ahead. You can.
Yeah, so that was just my question, because I was like, am I supposed to screenshot like every time that I put it into a group? I was like, or is it okay if I just take one screenshot for like one?
Yep, just one screenshot.
Okay, cool.
All right, I'm changing that to a Google Doc right now. I don't know why I put it a PDF. Weird.
Roxanne, really quickly, I'm so sorry to bother, but just so I know, for the least common multiple, so you're trying to find like the equal, I mean, like you just go up by like 21 and 15. Like, is there a quicker way to do that though?
Ah, interesting. There is a quicker way to do that. I'll
What
show
is
you
it?
real quick.
Yeah, please.
Show you real quick. So we have 21 and we have 15, right? Can you see my screen?
Yeah.
Okay. So look at prime factorization for both. They're nice because they're small, right? So, and then I'm going to use a Venn diagram. If these are factors of 21 and these are factors of 15, what would go in this overlap part? What is on both of these prime factorizations?
The 3.
Yeah, so I'm going to write a 3 in the middle and I'm going to mark it off both of these sides. Okay. Then put this 7 right here because it's a factor of 21, but it's not a factor of 15. And I'm going to put this 5 over here. Everybody okay with what I did? Does that make sense? So if you look, this circle right here multiplies to 21, right? But this circle right here multiplies to 15. That's how I know I did it right, right? Okay, so now here's the nicest part about this. What do you think right here is? Do you think that's the GCF or the LCM?
Isn't that the greatest common factor?
Yep, greatest common factor would be 3. If there's 2 numbers in the middle there, you're going to multiply them together. Yeah, so now the LCM is you're going to multiply all of these. Multiply 7 times 3 times 5. What that does is that gets rid of the duplicate factors, right? Notice 3 was in both lists. So then if I do 21 times 5, I get 20 times 5 is 100. 1 times 5 is 5. So that's 105. So my LCM is 105. So I love the Venn diagram method for finding the LCM and GCF. I think it's a little bit time consuming to do the prime factorization depending on your numbers, but it gives you both of those right away, right?
No, yeah, it's definitely easier than just because I was just counting up, like, but I was like, all right, what is it gonna hit, the greatest common factor?
Yeah.
But I feel like this way is much easier. So thank
Yeah,
you.
you want to know something else really cool?
Ooh, yeah.
That if I multiply 20 and 15, I get 315. You can just believe me, right? Like you could do it, but I really do get 315. Look what I get if I multiply 105 and 3. I also get 315. So it's a nice way to double check you get the right answer for the LCM and GCF. If you multiply the 2 numbers that you're trying to find the LCM and GCF for, that product will match the product of the LCM times the GCF. Isn't that cool to check?
No, that is nice. So if are we gonna have any like POILAs, 4-step methods? So I mean, that could be. I mean, are we gonna have any POILAs in the next couple weeks?
Like
this?
for sure, for sure.
So that would be like a verification step. Like we can show like the LCM times the GCF, and that would be a good verification. Okay. Yeah.
That would be a great verification. And I don't know why they don't teach this more. It needs to be taught more because it's visual.
Yeah.
Right. And it has a verification instead of they only teach that listing method, like you said, Madison, which is super annoying.
And that's the only one I knew. You just had to like add, you just had to keep on writing until and then you circled the common factor. And I was like, that's so annoying though. I don't get it. That's probably why I confuse factors and multiples.
Yeah, everybody does. Their vocabulary is very poorly on teachers say the wrong words all the time. Okay, good. I'm glad you stuck around.
Thank you so much. Have a great weekend.
You too. Bye.
Bye.
I was wondering if like the cake method is another way. I don't know if you've seen it.
I have, and I can't remember it. Do you want to show me it?
Yeah. How do you want me to show you?
Hold on. Let me stop sharing this. however you want. Do you want to write on board on the screen, or do you want to just write on paper? I don't care, either way.
I'm on my tablet. Let me see if I can share. Oh my gosh.
Bye, Kelsey. Have a good weekend. You should be able to share.
There we go. If it'll load.
I know it's always a mistake if it's or not. It looks like it's going.
There it is. Okay.
Yay.
So like with 21, so you'd have 21 and then 15. It's kind of like the ladder method, and 3 goes into both of them. So 21 divided by 3 is 7, and 15 divided by 3 is 5. So the GCF is the numbers on this side, and the LCM is all the numbers multiplied.
Nice. That's awesome. I love that method.
So would I be allowed to use that for like Poyolas and stuff?
Absolutely. Absolutely. That's a great method.
Okay. Yeah, and then if you need more steps, you just keep adding, and they call it the cake method because it'll keep going down and it looks like an upside down cake.
Yeah, good. Awesome. And you can do that on your LCM GCF homework if you want to.
Okay.
Perfect for sharing, Amanda.
Awesome. Okay, thank you.
Yeah. Sunita, do you have any questions?
No, I was listening in on stuff. I'm
Good.
gonna catch up. A lot has been going on lately.